Welcome to Naresh Technologies, and in this session I want to demonstrate to you about inheritance in object-oriented programming. So let us understand what is this inheritance. Inheritance. It's a mechanism of consuming the members that are defined in one class from another class. See, we are aware that class is a collection of members, and the members that are defined in one class can be consumed from another class by establishing a parent-child relationship between the classes. See, it's a mechanism of consuming the members of one class in another class by establishing parent-child relationship between the classes. See, generally all of us know one thing. What is it? All our parents' property belongs to us. So children get the right on the parents' property. So what is the why? Because that is law. That is law. According to law, all the property of the parents belongs to their children. Exactly the same principle can be applied here also. What is it? Suppose I have a class with a set of members in it, and I want the same members in another class, class 2. So if I want it, what I can do is I can copy paste all the code from class 1 into class 2. Copy the code in class 1, paste it in class 2. But understand, if you copy and paste the code like this, that is called as rewriting the code. We call that as rewriting the code. So rewriting the code will have a impact on the size of your application now. Application size will grow. If application size grows, ultimately there will be effect on the performance of the applications. So if you want to overcome that particular rewriting process and reuse the code, the best option that is available for us is inheritance. Simply what to do is establish a relation between the two classes. What relation? Parent-child relation. And once you establish a parent-child relation, watch it. All the members of the class 1 can now be consumed under class 2. Class 2 can consume the members of class 1 now. So that can happen for you if at all relations are established between the classes. So what I said to you, it's a mechanism of consuming the members of one class in another class by establishing parent-child relation between the classes, which provides reusability. So basically the advantage with inheritance is it provides you reusability. It provides you reusability. Why? Because I am just trying to consume the members defined in one class from another class. Not only another class here, you can consume from any number of classes like this. Means a class can have n number of children, and all the children can consume the members of its parent class. So that is the big idea about the inheritance. So it will provide you reusability. Okay, fine. Now, how to perform this inheritance? If you want to perform this inheritance, okay, you need to establish a relation. How exactly is it possible? Listen, I have a class A, and in this class I am defining a set of members. Now I am going to have another class here, class B, and this class B I want to inherit from class A, colon A. A very simple process how you can perform this. And now you can start consuming the members of A from here. You can start consuming the members of A from here. So that's the basic process how you can establish a relation between the classes. So if you just check out the syntax now, simple. Modifiers, this talks about your public, private and all these things. Class, that is a keyword to tell you are defining a class. Here, child class, colon, parent class. actually the terminology parent class, child class, you can also call them as derived class and base class. Means parent class or the first class what we are working can be called as a, means here A, this class you can call it as a parent, you can call it as base, okay, or you can call it as super also. Any terminology you can just use. Different people just call this in different way. So you can call with any name here. And what about class B? Class B can be called as a child or derived class or subclass. Whatever it is, all are same. I choose the terminology as parent and child, but even I call it as a base class or I call it as a super class, all are same. And a child, I call it a derived class or I call it a subclass, all are one and the same. But I will prefer to use the terminology as parent and child. Okay, fine. So this is the syntax how you can just use inheritance in your code, and is an example how you are going to perform. Now let us practically perform this inheritance in your application. And one important point here, what you know, in inheritance, child class can consume members of its parent class as if it is the owner of those members. The big important thing to understand here is child class can consume the members of its parent class as if it is the owner of that particular members, except private members of parent. So what is this except this private members of the parent? See, children have right on their parents' property. As a children, tomorrow I can take over my father's business. I can take over my father's property, cars, buildings, whatever it is, but I cannot take over my father's job. The reason is the job what my father is doing may be based on his qualification and his experience, and tomorrow I cannot take over his particular job now. So you understand that the job is completely private to my father and that is not inherited to me. But remaining everything, business, money, properties, whatever, I can take all these things. I can take over all these things except the private members. So exactly now also same principle. What is it? See, why I just used the word parent class can consume the members as if it is the owner is, I can drive my father's car as if I am a owner of the car. No one can stop me. Okay, so that's why I'm telling you here. What is that? Child class can consume the members of the parent class as if it is the owner of those particular members. Let us see practically. I'm opening a new project in Visual Studio. Console application, and let me call it as inheritance project. Okay, by default I have a class here called program, and I want to rename this class as class 1. Open your Solution Explorer and rename this class. Just let me call it as class 1. No issues. When I rename, it will ask you about renaming this name throughout the project. Yes. You can see now the class name is also renamed. I am deleting the main method. I don't want it. And let me define some few methods in the class. Public void test1. Console dot write line method 1. Next, public void test2. console.writeLine method 2. Fine. So like this, I am just going to define two methods in the class. Now, I want the same two methods in another class, that is class 2. Let me add it first. This is my class 2. I want the same two methods what are present in class 1 and class 2. So one thing I can do is I can copy the code in class 1 and I can come to class 2 and paste it here. But that's not going to be reusability, that is rewriting the code which affects the size of your application. So without doing that, what you'll do now, let us perform inheritance here, colon class 1, inherit. Once you perform this inheritance, class 2 contains the two methods in it. Why? All the property of the parents belongs to the child. And now you see, let's write a main method here. And next, create the instance of class 2, not class 1, class 2. C is equals to new class 2, creating the instance. And now C dot. When you say C dot in IntelliSense, you can see the two methods, test1, test2. So that's what I said you. Child class can consume the members as if it is the owner. You are able to directly by using the child class instance. That's what the point here, C dot, say test1. Now, if you see this test1, if you see the description here, what is it showing you? Void class1.test. Void class1.test. What is that? Yes, the method test1 belongs to class 1 only now. But what we are discussing here, class 2 can consume like a owner. Yes, no doubt about it. See, I can drive my father's car as if I am a owner, but still the registration name will be my father. Exactly. Class 2 can call the method just like the method is of its own, but internally the method belongs to class 1. So class C dot test1, C dot test2, and console dot read line. And let's execute the code. Yeah, if you watch your output now, you can just understand it was calling you the two methods, method 1, method 2 got executed. So right now we have currently created an instance of class 2 and we're calling the methods of class 1. What are the two methods? Test 1 and test 2. Let us add a new method into class 2. So a new method, public void test3. A new method was added now. Console dot write line simple method tree. And now coming below, I can call this method C dot. There are three methods right now. Two methods inherited from your parent class, and the third method is defined under the current class. You can watch C dot test3. But test 1 belongs to class 1, test 2 belongs to class 1, test 3 belongs to class 2. Class 2, this method is of class 2 on. So calling you all the three methods now. Let's run the code. You can watch all the three methods got executed. So currently, if you raise a question like how many methods are there in class 2, the answer is 3. Class 2 has 3 methods. Why? See, all the property what my father has given me plus all the property what I am earning is whole my property only. So what is my property means I don't say what I earned, I also say what my father has given me. So exactly how many methods are there in class 2 means I say 3 methods. 2 inherited from parent and 3 is the new method what you defined on your own. So total you have 3 methods under class 2. But what about class 1? Class 1 contains 2 methods. There are only 2 methods in class 1, but class 2 contains 3 methods in this case. So this is the process of inheritance. Okay, a very simple process. Simply put a colon and write the class name. But when you're working with inheritance, there are some few important things what you require to learn or what you require to remember. What are those? Let me tell you. One by one, we'll discuss. I have 6 important things to learn here. Let me teach you one by one. The first important thing, what do you know? The first important thing is parent classes constructor must be accessible to child class. Otherwise, inheritance will not be possible. Otherwise, inheritance will not be possible. What is the meaning of the statement? What is the meaning of the statement is, right now, class 1, class 2, both these two classes contains an implicit constructor. What is that? Yes, every class contains an implicit constructor if not defined explicitly. Okay, so we already learnt about it in our constructors session. So in the constructor session, I explained you every class contains a constructor that is implicitly defined if not defined explicitly. So right now, class 1, class 2, both these classes have a constructor. But understand the point here, if a constructor is implicitly defined, that is a public constructor, and that constructor is now accessible to class 2. Class 2 can access class 1's constructor now. But if at all an explicit constructor is defined in the class now, suppose class 1 I am defining an explicit constructor. If I define this constructor as public class 1 and writing some code in it, console dot write line, class 1 constructor is called. Class 1 constructor is called. So right now, come back to class 2 and execute your class 2. When you execute your class 2, see what is happening first. Class 1 constructor is called. Why? Because whenever the child class instance is created, the child class constructor will implicitly call its parent class as constructor. That's a rule. The child class constructor will implicitly call its parent class as constructor. So right now, child class also contains a constructor. What constructor? Implicit constructor. And that is now calling the parent class as constructor now. But parent class constructor is not implicit, it is explicit now. And under that I have written some code. Because I have written some code, that is getting printed. Even I don't define this constructor also, there will be a constructor. There will be a constructor. But be careful. When you are defining the constructor, if you don't use, if at all you are just going to use a private here, or don't use any modifier here. Don't forget, default scope for the members of a class in CSharp is private. Because the default scope is private, this constructor is not accessible to class 2. And if you try to run class 2, you will get an error. You will get an error. What is that error? Read the error message. If you read the error message, what's it telling you? Class 1 dot class 1. What is class 1 dot class 1? Class 1 is the class name, class 1 is the constructor name. This is class name, this is the constructor. Is inaccessible due to its protection level. And the error occurred in class2.cs. The error is in class2.cs. Why? Because whenever you create the instance of a child class, the child class constructor will implicitly call its parent class as constructor. Right now, class 2 implicitly, class 2 constructor implicitly calls class 1 constructor, but this is not accessible. Why? It is private. Already we have learnt it. What is this? In inheritance, child class can consume members of its parent class except private members of parent. So you cannot call the private member now. What is the private member? The constructor. Constructor cannot be called. And if the constructor cannot be called, inheritance is not possible. That's what I'm telling you. Parent class constructor must be accessible to child class. Otherwise, inheritance will not be possible. Okay. I'll just show you one thing. Watch. Let us define a constructor in class 2 also. Class 2. So here also I defined the explicit constructor. That's it. If I don't define also, it is present. But now explicitly defined. Run your code. And the problem I already demonstrated, it must be public. So let us make it public. Public class 1. And now tell me, is this constructor accessible to the child class now? Yes, it is. Now if you run this, first what is called? Class 1 constructor. Next, class 2 constructor. So execution always starts with parent class constructor. Why? When you create the instance of the child class constructor implicitly calls the parent class constructor. Suppose class 1 has any parent class 1 constructor will call its parent class constructor. If that has a parent class, it calls its parent class constructor. Suppose if you have 10 classes now and you create the instance of the 10th class, what is going to happen, it keeps on calling each and every constructor. 10 will call 9, 9 will call 8, 8 will call 7, 7 to 6, like this until 1, and execution starts from class 1 constructor and executes all the 10 constructors. I'll tell you the reason why to call the constructor, we'll talk on it, but that is the process. Here you may doubt, class 2 constructor is not public. Class 2 constructor doesn't require to be public. Why? Class 1 constructor should be accessible to class 2, not class 2 to class 1. When class 1 constructor should be public, if class 2 has a child class, then class 2 constructor must be public. If class 2 doesn't have a child class, there is no point of declaring it public, or if you don't declare public also, no matter. So that is the point. If you want, we can declare it public, but that's not a matter at all now. Okay. Now again, you can watch your output. First, what is called? Class 1 constructor. I'll practically prove you how the execution takes place. Actually, we have 2 classes in the project, but main method is in class 2. So execution starts with class 2, no doubt. So now execution starts with class 2's main method now. So let us do one thing. Let us add a breakpoint here. Let's add a breakpoint on this line. Okay. So how can you create a breakpoint? Just select your, go to debug, and you can just use toggle breakpoint. So once it's a toggle breakpoint, a breakpoint gets created, and now you can see a red color line here, a red color identification, background color changed. Now run your code. So when you're running your code, when the execution reaches that line, execution stops there actually. It won't go further. If you want to see the output now, if you want to see how the execution takes place, you can watch it by pressing F10. By pressing the F10, we can see the output. Okay, just watch F10. When I press F10, it moved to next line, next line, next line, next line, like this. Line by line execution, you can check it out right now. So F10 will take you to the next line and you can watch your output. So if you just watch one more time, let me start. Okay, execution stopped on that line. First F10. So that line of code executed now, watch your output. That line of code is calling you constructor 1, constructor 2. Next, again F10. So test 1 also executed, method 1. Again F10. Test 2 executed, method 2. Again F10. Test 3 also executed, method 3. So like this we can see the line by line execution. Okay, well, watch again. Start. If I say F10, it will go to next line. Actually, we call it as a step over. Step over. We have another statement called F11, that is a step into. What is that step into? It will step into the constructor now. Why? Whenever we create the instance of a class, implicitly the constructor of the class gets called. So right now, if I use F11 here, it will jump to the constructor. Watch it. From here, control jump to the constructor. And it won't execute the code in the constructor. Watch it. From here, it will jump to class 1. That's what I'm showing you. What is it? Whenever you create the instance of the child class constructor will implicitly call its parent class constructor. You can watch out now. Child class constructor is calling its parent class constructor now. And once it is calling the parent class constructor, the parent class constructor executes. Okay. Now you can use F10, come to next line. Okay. So just use F10 to come to next line now. See first, which constructor is called first? Class 1 constructor. Check your output. Back to class 2 constructor, and executing you class 2 constructor. Check your output. Back to the main method from where the execution started. Back to the main method where the execution started. So why I showed you is this to prove you child class constructor implicitly calls the parent class constructor. Is it proven that? So parent class constructor should always be accessible to child class. If not accessible, inheritance will not be possible. But the thing to understand is why it should be accessible. Why it should be accessible? The reason behind it is, if you call the parent class constructor, then only parent class variables will be initialized and they can be consumed under the child class. If the parent class variables are not initialized, you cannot consume them under the child class. If you want to consume them under the child class, must and should, that should be initialized. If not initialized, you cannot consume them. See, child class is dependent on parent class. So parent class must be initialized first, then only consumption is possible in the child class. That is the reason why it will call parent class constructor, initialize all the members there, and then you can start consuming them under the child class. So this is the first rule of inheritance. What is it? Parent class constructor should always be accessible to child class. If not accessible, inheritance will not be possible. This is the first important point. Second point. In inheritance, child class can access parent classes members, but parent classes can never access any member that is purely defined under the child class. See, one thing, according to law, children have right on the parents' property, but parents never have right on the children's property. It is only the children's responsibility to take care of their parents, okay? But legally, parents doesn't have right on the children's property. Exactly. Parent class can never access child class members that are purely defined in the child class. If anything is purely defined in the child class, parent class cannot access it. Watch it. Right now come to class 2, and in class 2 main method I am going to create the instance of class 1, that is parent class instance. P is equals to new class 1. Class 1 P is equals to new class 1. And once after creating this, what I am going to do now is I am going to call the members now, P dot, and call the methods. You can watch the list. It is showing you test 1 and test 2. It is not showing you test 3. Why is it not showing you? Because that is not accessible to you. And remember, if IntelliSense is not showing you, you cannot perform this. If you try to blindly do it, you will get off an error. IntelliSense should show you all the things now. So just test 1. I can call test 2. But if I try to call P dot test 3, even though that is not in the list, I am trying to type it over there, I will get an error. Execution time, I will get, when I compile, I will get an error. What is the error? Class 1 does not contain a definition for test 3 and no extension method. Extension methods all we will discuss about later, but class 1 does not contain a definition for test 3. There is no definition for test 3, and that is present where? In class 2, but that is a child class, and parent class cannot access child class members. So this is the second rule of inheritance. Delete this, execute. You can call the two methods. And right now watch, class 1 constructor did not call class 2 constructor. Class 1 constructor is responsible calling its parent class constructor, not child class. Class 2 is responsible in calling class 1, but class 1 is not responsible in calling class 2. So this is the second rule of inheritance. Third, we can initialize a parent class's variable by using the child class instance. By using the child class instance. okay, to make it as a reference. To make it as a reference. What is a reference? A reference is a pointer to an instance. A reference is a pointer to an instance which doesn't have any memory allocation. Okay. So for more idea, refer to my references video in the earlier sessions. Fine. Now, if you just notice it, what I am trying to tell you is, what is P? P is a variable of class 1. P is a variable of class 1. It's not an instance, it's a variable, uninitialized copy. Uninitialized copy. And you run it, you cannot call any members on a variable. You cannot call any members on the variable. What is it showing you, see? Use of unassigned local variable P. Local variable P. It's not an instance, it's a variable. Okay, fine. Now I cannot call any members on it. It should be initialized. How to initialize? Initialization can be done by using new keyword. That's a different story. New can be used for initializing, but watch it. Class 2. Class 2. C is equals to new class 2. What is C? C is instance of class 2, means child class. Now, actually I want to initialize P. Two options to initialize. P is equals to new class 1. This is a normal process, creating the instance. So P will be initialized and it is an instance now. We'll have a memory allocation. But now watch this. I can initialize like this also. P is equals to C. Means we can initialize a parent class variable by using the child class instance. P is equals to C. P is initialized. You can call members on P now. P dot test1. P dot test2. You'll get the output. Two methods are called. Why? P is initialized. How is it initialized? Actually, P doesn't have any memory allocation here. It's a reference now. So at this particular place, what is P means? P is a reference of parent class created by using child class instance. P is a reference of parent class created by using child class instance. It is a reference. What do you mean by reference? References of a class will not have any memory allocation. They will be consuming the memory of the instance that is assigned to initialize them. Just watch it. Have a look. Here, whenever I create the instance, memory is allocated for C. And this instance will contain the information of its parent class also. Class 1, class 2. So this is an instance. And right now what is P? P is a reference. And P is consuming the memory of C. It's only a reference consuming the memory of C. Memory allocation is done only for instances, not for references. References are just pointers to instances. So P will consume the memory of C. So right now if you just follow CP, both are accessing the same memory. Both are accessing the same memory in this context. But the point to understand is, even though P and C are accessing the same memory, using P, now also I cannot call any child class members. Using P, now also I cannot call any child class members. So what I am trying to tell you now, we can initialize a parent class variable by using a child class instance to make it as a reference, so that the reference will be consuming the memory of child class instance. Consuming the child class instance. See, there is a picture which will apply, which will reflect you. So this reference is consuming. Okay, but in this case also, we cannot call any child class, any this will be pure child class members by using the reference. So now also we cannot call any pure child class members by using that reference. The thing I am trying to tell you is using P, now also I cannot call test3. If I try now, see IntelliSense not showing now also. IntelliSense not showing. Now also if I blindly try like this, I will get an error. I will get an error. Same error what we have seen earlier. You can just check out. Run it. Error. Same error. Class 1 doesn't contain a definition for class 3. So why to initialize that particular thing? We'll talk about it. That's a different story. But initialization can be done. But why I'm telling about this is, once I say both are accessing the same memory, immediately you will think like, okay, using that reference we can call off the child class member. That's why I clarified you. Not possible. You cannot call any member from the child class that is purely defined in the child class. Is this picture clear? This picture is telling you P is accessing the memory of C. And now watch this picture. What is this? This is what I am showing you to make you understand. P cannot call class 2 members. You cannot look in the downward direction. Look always in the upward direction, but not in the downward direction. So P cannot call class 2 members, but using C, you can call class 1 members, class 2. But P can be used for calling only class 1, but not class 2. So this is the third important point in inheritance. What is it? We can initialize a parent class's variable by using the child class instance to make it as a reference, so that the reference will be consuming the memory of child class instance. But in this case also, we cannot call any pure child class members by using the reference.